Um, so he just sent the most missed questions out.
All right. I've got him up.
Cool, me too. Okay. Should we just each start working on the first one, or?
Yeah, let's do it.
Okay.
Oh my gosh. Oh, I hated this one.
I did too. I went to his office hour and asked for his help on it because I just didn't even get it.
Right. I understood the largest, smallest, and zero, but the 4 and -3 derivatives, I don't understand how to find the direction. That's the case.
What if we just do that part, since we
Right.
both got the other two? It's the same numbers even, I think, as on the homework. So like the answer is just gonna be square, what was it? Square root of 5, I think. Or 5. It was like 5 and -5 for A and B.
Yeah.
And then, okay, I'm trying to find my notes. Okay, so for the other two, there's two equations that you use, and like one of them I was like, that's one of our equations. So the gradient of f dot u equals -3 for e. And that I guess one of the formulas is that the like duf of p sub 0 equals the gradient of f dot u.
Right. Yeah, that's the definition of a directional derivative. Yeah, so.
I never found that formula, so I was pretty confused. And then you also use the magnitude of u equals 1. So those are your two equations for u, and then you solve the system of equations to find u1 and u2 as like the subpoints of u. Does that make sense? Like if your vector u has like an x and y, then you solve for like u sub x and u sub y using those two equations. Does that make sense?
Yeah, yeah. But I just couldn't draw the connection between solving for a single point, like solving a direction for a single derivative value, you know?
Yeah. Like what you're doing? Is that what you mean?
Once you get once you get the gradient of dot with u, and you get like coefficients to like the subcomponents of or the components of u equals derivative. I don't really know how to like solve for that. You can't really do it algebraically. So
that's why you have to use the magnitude of u as well.
Okay.
To make a system. So like the magnitude of u equals 1, so you know that the square root of like u sub 1 squared plus u sub 2 squared equals 1. And so then you plug that into your into the gradient of f dot u equals -3 equation.
Okay.
So I'll try writing it out.
But the largest derivative was 5. Or was it 1?
I thought it was 5, but let me double check, I guess.
I might be doing this wrong. Wait, is it when you find the gradient at that point, is it just that the magnitude of that gradient is the derivative, or?
Yeah, so, okay. It ends up being that because another one of the formulas is the magnitude of the gradient times the magnitude of u times cosine theta equals the directional derivative.
Okay.
Did you see that formula?
I recognize the formula.
So since the magnitude of u is 1, and in this case cosine theta, the slope is largest when the angle between the gradient and u is 0. So cosine of 0 is going to be 1. So it ends up being the magnitude of the gradient times 1 times 1. So it is just the magnitude of the gradient.
Okay. All right. Is that 1?
What was that?
Is the
magnitude 1? I got 5. What did you get for the gradient of f?
Oh crap! Yeah, it's totally right. Yeah, it's 2x minus y, and then 2y minus x minus 1.
Okay, yeah, that's what I got.
So
and
okay.
then that becomes 3 and negative 4.
So those Pythagorean up 5. I got you.
Yeah.
Okay. Whoops! I totally forgot about the negative. I am not the brightest when it comes to basic math.
One of my calculus professors said, like, you know how good you really are at algebra when you get to calculus.
Yeah. Totally.
So then B, let's see. So it's smallest when the angle is in the opposite direction. So cosine of,
or it's technically the most negative, you know?
oh yeah, so cosine of pi then, and it'd be negative 1.
Right.
Okay. Okay, so it'd be negative 5. And then, okay, so we have A and B. What did you do for C?
See, that one, I remember what I did, but I'm not remembering it right now.
I don't remember what I did for this one.
Trying to think of it. There was a trick, and it made it really easy to do. And I was doing a little bit of Googling. I found it out. When the derivative is 0.
Yeah, I guess that would be
Directionless?
Well, we'd still have a direction, but the slope in that direction would be 0. So it would be like a max or min point.
Right. How did I get that right? Because that doesn't even like, what did I even do?
I don't remember what I did. I think I ended up just doing the same thing that I did for the other ones. No, I don't remember at all, actually. I mean, you could do the same thing that I did for D and E, like set it equal to 0 and solve that, but
Yeah, and that would just be cosine, like the slope would be 0. So
right.
Cosine inverse of 0 is like pi over 2, right?
Yeah.
Yeah.
So then to find U, it would be like I don't know. Where would U be perpendicular to the gradient? I don't know. I don't remember what I did at all.
Hmm.
I think I just got it right by accident.
I think I did too, and the answer seems a lot simpler than the process. I'm kind of
Yeah, maybe the answer was 0.
yeah. Okay, so with the process that you use to find D and E, you kind of do like set it up like this. I know I kind of like made it a little complicated, but
Yeah.
you set up like that, and then you solve for each one.
Close, except for your second equation equals whatever your value is instead of equaling 5.
Yeah.
So
Yeah.
it would
So
equal 0 or
right. That's just the one I happen to plug in. It would be right now. It'd be 0 for D. It'd be 4, and E would be -3.
yeah.
Okay. I'm gonna try that real quick. I'm gonna set it equal to 0.
Okay. I will try that too after I put my baby down.
Already.
The gradient's 3, -4, right? Or is it -3, 4?
3 and -4.
Okay.
Yeah. And I just got 4/5 for the direction in X for C.
Okay.
So U of X is 4/5, and then U of Y equals 3/4 times 4/5 is 3/5. So when the direction is or when the derivative is 0, the direction is 4/5, then 3/5.
Okay.
So okay, I found yeah using the solving method. I don't know if there was
Okay.
another method, but
I'm almost done solving that.
yeah, you just do a little combination, then get it all equal to U of X squared, and the square root is nice.
Okay, wait. So first you're gonna square both sides and then you're gonna like solve for one of the u sub ones, right? Or
Yeah.
did you do it the other way? And okay, so you plugged in that into like the gradient equation?
I actually did it the other way. I solved for U of Y on the bottom
Oh,
equation, and since that was pretty simple, you didn't have to do any square roots before. So it ended up being U of Y equals 3/4 U of X. Yeah, if you wanna see what I did, like
yeah.
I started off there. So I started off there actually. I
Oh, okay.
I got that equation from the bottom equation, and then I plugged that into the top one. And since the top one is equal to 1, you just square both sides and becomes U of X squared plus U of Y squared equals 1.
Okay, that makes more sense.
And then I plugged in what I got from the bottom equation into the top equation, and then solved for U of X.
Okay, so then you have 4 4 u sub 2 over 3 squared plus u sub 2 squared. No, u sub 1.
And it takes a couple steps, but it's pretty simple after that.
Okay. And then, dang it, what did I do wrong? The answer is 4/5, right?
Yeah.
Oh, I have to take the square root.
Mm-hmm.
Okay.
Yeah, it's 16 over 25 times 1. If you solve it all through, you get
Okay.
and then you square it both sides, it's 4/5.
Okay, cool.
Then you have a pretty simple equation after that to find y. U of y.
Okay, yeah, just multiply by 4 and divide by 3. Okay, cool.
Yeah.
All right, so 4/5 and 3/5.
Mm-hmm.
Okay.
I'll go through
Let's do...
or
Yeah. After you square the... Oh, I guess it depends on which way you did it. Did you plug in u sub 1, and so you're squaring like 4 u sub 2 plus 4 over 3?
Yeah, use of 1 or use of y?
U sub y.
Yeah, I solved for use of y, so I got 3 use of x minus 4 all over 4, which I just turned into 3 use of x over 4 minus 1.
Oh, okay.
And then the square that I got for that, like when you plug it into the next one, you have to square it out. It's 9/16 c sub x squared minus 3/2 c sub x plus 1.
Okay.
Yeah, and like I don't see any kind of way around that, so I just did it.
Yeah, it's kind of messy, huh?
Yeah. Okay. Yeah, no, there's no way to just simplify that if it's all equal to 1. So, but it does combine. It's pretty good after that.
Hmm.
Okay. It got weird but not undoable. I got u sub x equals 0 and u sub x equals 24/25.
24/25.
So
Okay.
before that, I got u sub x squared plus 9/16 u sub x squared minus 3/2 u sub x plus 1 equals 1.
Okay.
So the ones canceled out, and so you could like do 25/16 u sub x squared minus 3/2 u sub x equals 0 when you combine everything.
Okay. Okay.
And so u sub x equals 0 because one of them factors out to 0, and then u sub x equals, when you solve for it, it's 3/2 times 16/25, which is 24/25.
Okay.
So it got weird but not undoable, and kind of still pretty solvable.
I think I messed up my algebra somewhere, but
Yeah, it's kind of messy. So
yeah. Well, I think like since the next one is like exactly the same, let's just go to the next one then.
Okay. What's 18/25 minus 1?
Negative 7/25.
Negative 7/25. Okay. So our answers for that one are 8 equals 4 when the direction is 0, -1, so it just goes straight down. So whatever the slope is, I don't even know, but that's the answer. And then the second answer for that, because there are two, when it's not the minimum or maximum. Oh, okay. Now I understand. Okay, so the direction of when it's 0, it has to be perpendicular. You probably said that earlier, didn't you? Okay.
I did figure out that it was perpendicular, but I didn't figure out how to then figure out what the direction was. But I guess it would just be like the negative switch of those. So.
Oh gosh, I just realized that. That's what I realized. So that's just kind of simple. But the second answer for when it's equal to 4 is 24/25 and negative 7/25, because it works out that way.
Okay, yeah.
Okay.
Okay, yep, that's what I got too.
Mm-hmm.
Cool.
All right.
The directions and the values. Okay. Can you hear my baby in the background?
Yeah, it's cute.
He's not very happy right now, but he ate, so nothing else I can do for him.
Right. So, 2 plus 3. Oh, okay. There's a trick.
I don't think that I'm doing this right.
I'm feeling like I'm running on rocks. I'm gonna trip any second, but I think I might be on the right track. Oh, dang, yeah. I used the quadratic formula at the end. I couldn't figure out the factor, but
does it come out nice when you did the quadratic formula?
It took a few tries, but yeah, it came out -9 plus or minus 16 all over 25. So those are numbers that are familiar. It'd be -25 over 25 and 7 over 25, which is weird, but makes sense. It's a -1 and 7/25.
Okay, that makes sense.
What did you end up with in the?
Well, when I did the quadratic formula, it never came out of the square root, so I have 12 plus the square root of 30 over 6, but I know that that's not the right answer.
Yeah, I think I probably would have gotten there faster if I just like plugged it in straight up. But okay, so before that, when I plugged everything in, I got 25 sixteenths use of x squared plus 9/8 use of x minus 7 sixteenths equals 0. And since all of that equals 0, I just multiplied everything by 16 to remove the denominators.
Oh, okay.
So 25 use of x squared plus 18 use of x minus 7 equals 0. And that gives you big numbers to plug into the quadratic formula, but I kind of like tried my hardest and it worked out.
Okay.
So on the quadratic formula, it would be -18 plus or minus square root of 18 squared minus 4 times 25 times -7. So that just makes the inner thing positive. And that's all over 50. And that kind of looks ridiculous. So what I did was I realized that 18 was 2 times 9. So 18 squared would be 4 times 81.
I did it with I solved for use of y instead.
Okay.
So my numbers don't match yours, but maybe I'll try doing it that direction instead just so I can see where I'm going wrong.
Right. Maybe should be. Yeah. Like it won't be exactly the same, but the process will be similar.
Right. So I just I have 19 u sub y squared minus 24 u sub y plus 6. So
Okay.
I don't know if that's right.
I don't necessarily like mathematics all the time. It kind of stops me, but I've kind of done a couple of things. I'll just share my screen real quick. I'm actually sort of proud of this. This one. Yeah. So you see this screen?
That's awesome.
So I figured since I was just after a while, I just give up and use Mathematica, after crunching the numbers. I knew I was doing the math right. It's just somewhat.
I've totally been doing that, especially this week. The problems are just so time consuming. I don't have time to do them all by hand.
Right. And the time consuming part for me was I just had to redo them over and over again,
Yeah, exactly. So, you just make a mistake somewhere and have to start from scratch.
Okay, so I plug in all my things up here.
Okay.
And then here is the center of mass calculator, and here's the moment of inertia calculator.
So you just change the values at the top.
Yeah, and you just press Shift Enter each time, and it'll give you new values. Oh gosh, those are not. Never mind. Okay, so sometimes it doesn't work, and I also have one for when it's the other way around. So.
Have you done lots of programming?
I have taken a CS class and
I was gonna say you set that up more like a computer program than anything I've seen in Mathematica before, but
yeah,
to have the variables at the top and
right. Yeah, so like it's just like a style preference to do that. My physics teacher would always do that. So like before I even took programming, I didn't like understand this, but now that I have, it's similar, but it's more like okay, so it's like a graphing calculator, but then the way programming works its way into it is that you have functions.
right.
So like honestly, it's just like you have to get yourself used to the idea. This is the double integral. Or oh gosh, I stopped sharing my screen. So this. Who's doing it? Ah, okay. So this is you just got to get used to the idea. This is the double integral.
Okay.
And setting it equal to this letter is putting this value into this letter. That's pretty much all I do with like that's all programming has to do with it. And then the other way is just you got to set it up and it does it all for you. That's pretty much it.
That's cool. Yeah. Thanks for showing me.
Yeah, no, sometimes I geek out, I guess.
What is your major? Are you in engineering?
Yeah.
Okay.
Electrical engineering. I don't know if I'm gonna stay.
What was that?
I don't know if I'm gonna stay in it. I might do something more computer programming because it's.
Oh yeah.
It's not that hard actually. There are just like two concepts that you got to learn in the first class, and then you just use that all through programming. And I had no idea before I even started. So
that's cool. I did one programming class and I really liked it, but I don't think I could keep going with it. Like I did fine in that class. I got an A, but I think anything more complicated, I would just be lost.
Mm-hmm.
Okay. What were the numbers that you had for your quadratic equation?
So what I got for x, I got -1 and 7/25. I'll plug those into y real quick.
Okay.
So the first y value would be 0 because -1 plus 1 times 2/4. That's my equation.
Oh right.
Y.
Yeah.
First one would be 0, and then 7 plus 25. That's 32, right? Yeah. Okay.
Yeah.
So 24/25 is the second one.
I got 27/50. Okay, let me do that again.
I think. Oh my gosh. What I was trying to do with my mathematic in the first place was just like literally use the solve function and do like, what did you have for your use of y equation equals 0? Like 16y squared or whatever use of y squared.
Yeah, although I added the use of y squared into it, so it ends up being 19 use of y squared minus 24 use of y plus 6.
Minus 24 y use of y plus 6?
Uh-huh.
Equals 0. Okay. Oh, those are ugly.
Yeah, I don't know. I must have done something wrong before that because
Okay.
I know it's not supposed to be that ugly.
I'll do it by y real quick. Use of x equals 4/3 use of y minus 1. Is that what you had for use of x?
Say that again.
4/3 use of y minus 1? Or is that similar to it? Is that?
Yeah.
Yeah.
Yep. Okay. Oh, I didn't split it apart like that. I just squared the whole thing.
Mine was split apart like that because like I had like 3 use of x minus 3 all over 4, so I just did 3/4 times use of x plus 1 just to make it simple.
Okay.
It'd just be like a binomial squared.
Okay. Okay. That will come out a lot cleaner. Let me try that really quick.
That was how use of y ended up. Use of x is x is like separate.
Oh, I know why all my answers were coming out wrong. I forgot to square the 3. Haha.
Okay. Okay, so are you still doing? Oh, so the answers would be 0. Okay. Are you still doing it to use of y or?
I am kind of doing it both ways at the same time, and I haven't finished either of them.
So for use of y, did you get 25/9 use of y squared minus 8/3 use of y equals 0?
Minus 2 equals 0 is what I got.
Minus 2 equals 0? Because what I got was 4/3 use of y minus 1 squared was like 16/9 use of y squared minus 8/3 use of y plus 1. So plugging that in would be use of y squared plus 16/9 use of y squared minus 8/3 use of y plus 1 equals 1. The ones cancel out.
Equals 1. Why does it equal? Oh, that's why it equals 1.
It just does.
Okay. Okay, yes.
Yeah.
Okay, so many algebra mistakes. Okay.
It's so many to make, I swear. This is like a nightmare right now.
Yeah, definitely. Okay.
Before I even realized we could do algebra with this, like, it was an algebra nightmare.
Okay.
No worries, bro.
Okay, so then I got... Yeah, okay, so then I got -1 for one of the values, and use of y, 25 use of y minus
7/25.
24 over 25. Boom! Ha.
Yeah.
Okay.
And then use of y equals 0, and use of y equals 8/3 times 9/25, which is, I don't want to do that in my head, so I'm going to write it out. 24 25. Cool.
Okay. Oh, man.
Bada boom, bada bing. Okay.
That was painful.
Okay.
Okay.
I wasn't able to do that on the homework. I think I straight up skipped it.
Yeah, I didn't get it right on the homework either.
So there's that. We learned something today.
Yes.
Have you ever seen Scott Pilgrim versus the World? It's a weird
No.
one. We wouldn't have it's got like so many famous actors in it, but it's such a hipster movie. Like at one point Michael Cera is in it, and like Michael Cera is just like, "What? I feel like I learned something," and it's just
That's
the
a
most
funny one to
joke,
quote.
right?
What's it called? Scott Conan?
Scott Pilgrim.
Oh, Pilgrim.
Yeah, it's just weird. It makes you feel like you're in a video game the whole time, and it's like, I don't know. It's an acquired taste, I guess.
Okay. Cool. Okay, let's get this next one done. Among all the points on the graph that lie above the plane, find the point farthest from the plane.
I don't even remember this.
I remember doing it, but I do not remember how. Also, my notebook's all out of order now because my baby got to it and ripped out all the pages.
Oh. Oh, gosh.
This was week 10. Okay. What? This one was like using the constraint thing, I think. The Lagrange.
Ew.
The Lagrange multiplier, I want to say.
Okay, that's why I don't even recognize this. That might not have done that either.
Oh, okay.
It wasn't a really good week for me.
Me either. I skipped a whole bunch of problems as well. Let's see. Where is this? Yeah, I'm not excited to get my quiz back from last week.
Yeah. That was funny. The other day I woke up to a text saying, "Your quiz has been graded. You have an F." And then I realized I never submitted it. So I was like, "Good, submit." Like I had it all done like on Saturday and I had it all uploaded, but I was waiting for it to upload and I forgot about it and closed the window.
Oh
So I thought I
no.
submitted it, but I did not. And I never checked back on it.
Did you email him? Did he let you like
I submitted it late and like put a note on it and like I got it back and I got a C minus. So like sounds good. So.
Okay. Okay, so all the points of the graph above the plane. Find the point farthest from wait, the point farthest. I did not. So you want to maximize the distance. So you're trying to maximize the distance formula. So that becomes your f of x and y. And then your g is the constraint. But this looks like two constraints. All the points that lie on the graph above the plane. Wait. Maybe just the second part is the constraint. I can't find my notes for this one. 2.7.49. Find where the oh, here we go. Yeah, okay, so it's a Lagrange multiplier. So the formula is you're going to be solving 0 equals the gradient of f minus lambda times the gradient of g.
Yeah. And when you optimize stuff, you set L equal to 0?
Yeah. Okay. Well, the gradient of L.
Mm-hmm. Right. At one point, I understood this, but this section I might need a lot of help on. I think I did well on the test itself, but other than that, I don't really think I'm gonna know much of that.
So let's see. F of x is what we're trying to maximize. And so we're trying to maximize the distance. And the distance is, what is the distance? All the points on the graph that lie above the plane. Find the point farthest from the plane. So it's the distance from the graph to the plane. We're trying to maximize the distance from the graph to the plane.
Mm-hmm.
So then it's going to be distance equals the square root of, I don't even know how to write the distance equation for that.
Well, it could be. It wouldn't just. So with the plane. Okay. How is a plane supposed to? I don't really know how the plane's supposed to come out. It's not straight up and down, but when you set a plane equal to 0, what does it do?
It's just like, you know how you have like ax plus by plus cz equals d?
Right. D is just the spacing of it. And it's,
Yeah.
okay, when D equals 0, it intercepts the origin. That's all it does. Okay, so that, and then it's most slopey with respect to Z. So like instead of being like normal like diagonal, just kind of lays across all of them, intercepts all of them at like at the intercept of 1.
Yeah, okay, that makes sense.
It would be Z would be 3 times higher, and Y would be 2 times higher than X. But translate it to like it intercepting at the origin instead of the intercepts, you know?
Okay.
So it'd just be kind of like askew a little bit, but through the origin is the important bit.
Yeah, and then the other one is just going to be elliptical paraboloid, so just a bowl.
Right. So minus x squared minus y squared.
Yeah, it'd just be an upside down bowl.
Yeah, and it would be all the cross sections would be circles. They'd be evenly eccentric, or not eccentric ellipses. I don't even know.
Oh yeah.
Yeah. So
it'd be a circle.
So the distance would be different in every little plane. So I don't know. I would have honestly done the help me solve this on the math lab. I wonder if you can still get to it. Huh, I'm gonna try that.
That's a good idea.
Oh, no, I don't want to go to chem. That's a painful class. Okay, sign in.
Ooh. Man, these are taking a lot longer than it normally takes us.
Oh. Sorry, I accidentally glanced to the next problem, and it's another Lagrange multiplier problem, but it's a lot simpler, even though it's like a word problem.
Oh, number 3?
Yeah.
Is that what you're talking about?
Yeah.
Doubling. Oh, I remember figuring out this one, or like filling in this one. You just had to like fill in the pieces.
Right. Okay. Oh, I found it on the homework. Closest to you.
I bet the only reason that this one is on the like most missed problems, this number 3, is just because everybody skipped it because they didn't get that far.
Yeah, true. Where? What problem is this? Do you know?
I don't.
Because I can't find it. Was it on the Lagrange multipliers one, or was it another one?
Let's see. It says 14.7.49. So.
Oh, 14.8.31 is the week 10 question. So it would be the section before that. So I'm on 14.8. That's the Lagrange multipliers lesson. It would be right before that.
Okay.
Instead of lesson 4, it'd be lesson 3.
There we go.
Which isn't really the same thing, but
14.7.
extreme values and saddle points.
Yeah.
Huh. So I actually did that one. Oh, never mind. I didn't do all of it. Yeah, it makes sense.
Oh yeah, I skipped this one. Okay. I just like they were so time consuming that on this assignment I just was like, I'm not doing 5 more of these problems, and I just didn't.
Okay, so I found the question. Among all the points in the graph, z equals 11 minus x squared minus y squared, that lie above the plane x plus 5y plus 7z equals 0. So it's the same, not the same numbers, but the same thing. Nope,
Yeah.
It doesn't have question help. That was where it probably stops, is when they stop giving you question help.
Like, okay, I give up.
Oh my gosh.
Let's take a look at the other one first. Let's take a look at number 3.
Mm-hmm. Yeah, because I actually tried looking up Lagrange multipliers on Khan Academy because I didn't understand them like at all.
Mm-hmm.
And they had a question about this, and it seemed this made Lagrange multipliers seem simpler. So I think I remember how to do this. You make an equation based on all the production output is your equation, is your function of 2 variables. Like labor hours is x and capital invested is y, and then your production is your p. So dependent on your labor and your production. So they just give you an equation, whether it's right or not. I don't even know. It probably is. They're just constants in there. Where k and a are constants, show that doubling both labor and capital results in doubling of production p.
Okay, so so then you plug in 2x and 2y in for x and y, and then you show that equals 2p.
Yeah.
By doing algebra.
Yeah. And then b is where your Lagrange multipliers come in. And I remember you have to make an equation, and that's your constraint. And the constraint turns out pretty nicely because it's just like linear.
Right, okay. So
b of xy equals k, x to the alpha times y to the 1 minus alpha.
Okay, so your f of xy is going to be 120 x to the 3/4 y to the 1/4, right? Is that what you got?
No, I don't really. I mean, like, I'm serious, right?
Just plugging in 120 for k and then 3/4 for alpha, because that's given.
Okay, so are you on B?
Yeah.
Okay, it's just algebra. So,
yeah. Were you going through A still?
Yeah, no, but I totally get it.
Yeah. Oh, sorry, I thought that you were talking about B. We can do A more.
No, we're good. I understand A. That's the easy part.
Okay.
So 120 x to the 3/4, and then y to the 1/4.
Yeah.
Okay. Assume each unit of labor costs $250, and each unit of capital costs $400. That the total expenses for all costs cannot exceed $1 million or $100,000.
So then
you make an equation based off of this. So I think since, like, if they're proportional, you would write like x over the first number or whatever, like it corresponds to x over that number plus y over the next number equals the limit, like equals $100,000. But if they're inversely proportional, you use them as multipliers. You are like coefficients.
I used them as coefficients, I think.
I think they use them as coefficients in the video I watched. So yeah, I think that's what we do.
Okay, so
so labor is x, so 250x
plus 400y
y equals 100,000.
Equals 100,000. But for g of x, you always have to make it equal to 0. So minus 100,000 equals 0.
Okay. That should be just cool.
Okay, and then you just would do the 0 equals the gradient of f minus lambda gradient of g.
Mm-hmm. Okay. It would just be equal to g of x just has to be equal to constant, right?
Right.
The g, the partial, the derivative of g has to be 0. I remember equals 0 equals the derivative or whatever.
Oh, right.
Yeah. Okay. So just that's fun right now. So g of x equals 0 equals 250x plus 400y minus 100,000. Cool. Those up top. And L of xy equals P of xy minus lambda times G of xy.
F of xy minus lambda times g of xy.
Yeah. So our f of x would just be P of xy, right?
Yes.
Or the
yeah.
X, yeah. So I'm just gonna write it like that for now.
Hey, hold on one sec. Somebody is here.
Cool.
It's a group meeting.
Mhm.
We're usually done by now.
Did you hear Nana has a girlfriend? I did. Oh. Okay. That's my dog. That's your dog. He has another pair of or maybe, yeah, you have a microphone outlet on your laptop? Probably. Yeah, so it's just microphone. All right, that'll. Thank you. Yeah, you're welcome. What was your other question? I was looking at this mom that was bringing the kids into the theater or something, and she was wearing workout clothes. Have a membership somewhere else. I don't know, but
Are you gonna stay for a sec, or do you just? No, I just. I always need people, but I am not done with my meeting, so.
welcome to come to my place if you want.
Okay.
I'll be there till about. I work at 2, so I'll be there till like 1:30.
Okay. Cool.
You can come eat lunch with me.
Okay.
Or you can
That sounds fun. Okay.
Shower and
Okay. Cool.
let me know if you are coming now, because it's not.
Okay, I'll text you.
Bye.
Okay.
Bye.
Okay, I'm back.
Alrighty.
So this is when I was doing this on the homework, that's where I stopped after I wrote the equation because it asked you to just like fill in the equation.
Yeah.
And then I just stopped because solving them takes a really long time sometimes.
Yeah.
And I had been working on it for forever. Let's see. So
So taking each partial, so the partial of L with respect to X,
okay.
I ended up getting 120 x to the 3/4 over 4 times y to the 3/4 all minus lambda times 250.
Wait, 120 x to the 3/4.
Over.
Oh, that's after you took the partial?
Yeah. And so the reason it's over is because when you take the derivative,
Don't you get x to the negative 1/4?
yeah, okay, maybe I did these backwards. Oh my gosh, that's funny.
Oh, like you did like an integral instead?
No, I did the partial of x, the partial which I took to x, I just accidentally did the partial with respect to y.
Oh, okay.
Which is funny because the next one I actually take the partial with respect to x. So it's like the partial with respect to y minus 250 lambda, which is backwards and like also not backwards. Like, so
you only did it backwards half the time.
Right. Selectively backwards. That's me. Okay, so with respect to x, I got 120 times 3 times y to the 1/4 over 4 times x to the 1/4 minus 250 lambda.
Okay. Yeah, that matches what I got.
The y would be 120 x to the 3/4 over 4 times y to the 3/4 minus 400 lambda.
Y to the negative 3/4, right?
Yeah. Or yeah, y to the negative 3/4, so it's on the bottom. I just put them on the bottom.
Okay.
So eventually, when I solved for lambda, it took a couple more steps. I got lambda equals 30 over 20, like 30 over 250 times the quantity x over y to the 3/4.
Okay.
I remember Khan Academy doing that. And it also, lambda also equals 90 over 400 times y over x to the 1/4.
Okay. Let me see. Oh, and then your third equation is the g of x equals 0.
Mm-hmm.
Man, these are just so painful to solve.
Mm-hmm.
Let's see. When they're like 100% linear, you can just like plug them in a matrix and have it solve them, but
This is like trippy.
okay, so
Who? Okay. I kind of stumbled on this, but like when I worked the y over x to the 1/4, and the equals to x over y to the 3/4 together,
Okay.
it was kind of weird, but it worked out to be um, y over x to the 1/4 over x over y to the 3/4 equals y over x.
Oh, okay.
So if you like if you just set all
Divide
the
everything
numbers on
by.
one side and all the letters on the other side, and then put like kind of distribute out the 1/4 power out of each of them, like they end up being y times y to the third over x times x to the third. So it's y to the fourth over x to the fourth, and all of that inside a 1/4 power. That all ends up being y over x. So I ended up getting y over x equals 8/15.
Okay, yeah, that's what I just came up with as well. Or I did x over y equals 15 over 8.
Right, which is the exact same thing. I don't really know what to use that with from there.
Okay, so then you could do like x equals 15/8 y.
Okay.
And you plug that into your g of x equation at the beginning.
Okay, that makes sense. So g of x would equal 250 times 15/8 y
Yeah.
plus 400y minus 100,000.
So, oh, that's ugly. For y, I got 16,000 over 139.
Makes sense. Yeah, I'll just believe that. Oh, my roommate's back. Okay. I swear my roommate's not imitating your baby. He just makes that sound all the time.
You're fine. Why didn't that come out nicer? I must have done something wrong.
I don't know.
Man, this is like our longest meeting ever. I don't know why this is taking so long today. Probably because the homework took so freaking long last week.
Right, and this week it's all like double integrals, which is like I had no idea all areas were just double integrals, but the inside was just bounds. Like you know how that never clicked in my head, and I was always so mad that you had to memorize a different formula for area of polar sections. But that's just because like when you set dA equal to like dx dy, when you set dA equal to like a function of dr and d theta, dA equals r dr d theta. So when you like solve for it, you have to integrate r and then put the bounds inside of them. So it's like 1/2 r squared theta is inside the integral to find the area.
Yeah.
That always made me so
did like explain that part to me before, but yeah, I didn't connect that it was that was the double integral.
I was just like, it took me so long. It was like, these are so complicated. Why don't I just use a single integral? And then I'm just like, oh, wait a minute. These are all single integrals. Like, you just have to like put the bounds and subtract them into a formula that you've known forever. And I was like, oh my gosh.
Yeah.
Yeah.
Okay.
So
Oh, sorry. Go ahead.
We have our maximum y and then our maximum like x if we use our like x equals 15/8 y or 8/15 y. My bad. So we got our answers, I think. So I think we can call this meeting good since we've gone like 20 minutes over anyway, or 10, 15 minutes over.
Really quick on the quiz, what did you get? Which problem was it? There was just one that I'm pretty sure I got right, but he marked it wrong. And I think he just couldn't read my work. So I wanted to double check what you got. Where is it though?
Oh boy, I can't find my quiz. I don't know.
It'd be the week 9 one, right?
Week 9 quiz?
Yeah, week 9.
Yeah, that makes sense.
Has he not sent yours yet? He just sent mine yesterday, so maybe.
He sent mine yesterday at like 6 in the morning.
Well, okay. Could we just go through and like compare answers for ones that we got wrong?
Yeah.
So I got number 2 wrong. Did you get that one right? I
got number 2 partially right. I got it's 8 out of 16. I got an 89 on this quiz. What the heck is wrong with this? Something's got to be up. Sorry, I'm very pleasantly surprised right now. I have no idea why this is like, I guess, such a high score. That's okay. So number 2. Oh, ew. Oh, I didn't like these ones. But I think I did it reasonably right. So the integral over the curve, the line integral over curve of y dx plus xz dy plus yx dz, where the curve is r of t equals 3t square root of t and 3t squared? Squared. Sorry, I can't tell what I write sometimes.
So when you like do each of those separately for the integral of y dx, I got 3.
Okay.
And then for the integral of x, oh, maybe that's why. Am I missing something right there? Should it be yz dx?
Integral y dx, that's what I had.
Okay.
But y equals square root of t. So it should the integral, the first integral y dx should be 3 square root of t dt.
3 square root of t dt.
At least that's what I had.
Okay, what on earth was I doing?
I don't know. I don't know what I was doing either because I did it all as one integral, and that's probably
integral of y with respect to x, and y is the square root of t, so it'd be the square root of t times x, and x is 3, so 3 square root of t. Okay, yep, I just completely did everything wrong then. Oh, that's frustrating. Okay.
I always thought it'd be easy to correct on the quiz.
Yeah, that's true.
So xz dy, or dy equals dt over 2 square root of t. Is that right? Okay. Yeah. Dy would be equal like 1 over 2 square root of t times dt, right? Or dy dt equals 1 over 2 square root of t.
I think so.
And
I didn't get this one right, so.
Yeah, sounds good. I think these all seems just simple and all with respect to t.
Yeah, man, what on earth did I do that did you get 9 for the second one?
I did them all as ones, so that's probably what I could do differently. So,
okay, that's fine. I think I can figure it out from here.
3 times 2 over 7. I think I got 6/7 times 3. So I think I got 18/7 for the second one. So I probably did that completely wrong.
Or I did it completely wrong. What? Oh, you know what I did? I didn't even use the like. What the heck was I doing? Yeah. I just used like the points for everything instead of using R of t for x, y, and z. So that would be why I got it so wrong.
Alrighty.
Okay, 5b was the next one that I had a question on. Did you get 0?
5B, I got 9 out of 9. I got 5B right.
What did you get for the answer?
5B. So we're trying to find the value of like the integral over curve C times f dot t ds, which is like f dot dr. The answer was 4 sine 3 plus 9 cosine 1 minus 1. It was kind of a complicated process, but it was basically dotted with each other and solved, or dotted with each other and integrated and then solved.
I have some work that looks kind of similar to that. I am a little confused though because.
What did I do?
Oh, good. He passed out.
Good. The child is not conscious. Okay, so we used the. What did you get for 5A?
I got 4y sine x plus x squared cosine y.
Okay. That's all I used. Integral over curve C of f times t ds equals the original function.
Did you say TDS equals dr?
Yeah.
Okay, that's the part that I couldn't figure out. But I had found somewhere that said if the gradient of f equals like the f vector, if they're equal, like if you can go backwards, if the potential equals the gradient of f, then f dot TDS equals 0. So I just wrote that down and circled it. But apparently that was not right.
So so this is kind of like I scribbled it all out and like there's more simplification to do.
Okay.
But t, using the bottom two little equations in the parentheses, t is r prime over magnitude of r prime, and then s is the magnitude of r prime.
Oh,
so x prime of t squared plus y prime of t squared equals r x prime of t squared. So gs equals magnitude of r prime dt. And so it all cancels out to be ds times unit vector t equals dr.
Okay.
It's essentially the change in like drd, like the change dr, the magnitude of that, but in the direction of where, like in the direction of r again, because that's what t is. It's the direction unit vector of r. So it's just like it's the magnitude reoriented to its original position. So TDS is just dr. But so looking at my work, all I did was plug x of t and y of t into f of x and y. And then I used the,
Did you use the f of b minus f of a?
Yep.
Okay.
Yeah, f of x of f of x of b, y of b. Oh yeah, so just I put it all in terms of t using the parametric equations, and then I use the like f of 1 minus f of 0, and then got all those numbers because of it.
Okay. I started to do that and then I crossed it out. Wonder why. Okay. Okay, I think I can figure it out from there then. Okay.
Okay, so we both got the same answers for f of x and y. I don't know what I did wrong on the 5A, but I got an 8 out of 9 on that. I got the right answer, but I didn't get all the
On
points.
5A, you got 8 out of 9. Oh, well,
Yeah.
maybe you didn't like show enough work or something. Maybe he was grading your work.
Okay.
I don't know.
I'm not really mad. I got like an 89 on this quiz, so but
Yeah.
just confused as to what exactly I did wrong. I guess I didn't show enough work.
Okay.
Six, 606, 506. The only other one I got, I missed the point on 6C.
I missed the whole thing on 6C.
I had to Google this. Actually, I kind of broke a rule, but I did not know what the curl of G was.
Yeah, it wasn't on like our anything.
Yeah, so it wasn't in any notes. I eventually I found it like the bottom of a Wikipedia page under gradients. It's the gradient time. It's the gradient cross product with the gradient of G. So it's essentially the second gradient of G.
Okay, that's kind of what I figured out as well, but I guess I didn't do it right.
But here's the trick. It was super. You have to take like a. It was really complicated because you had to do the cross product with it. So it was the gradient cross product with the gradient of G, which is, where is this bit up here?
Why do you do a cross product? I had a dot product written down.
Because the cross product was its definition.
Huh. Okay, so
I can share my screen real quick.
I must have just written it down then wrong. Because I had the dot product instead of the cross product, which would explain why I got it so wrong.
Yeah. So the cross product ends up being that little formula that I wrote right under 6C. So
okay.
The curl G equals a gradient cross product with a gradient of G. So it'd be like the partial of GZ with respect to Y minus partial of GY with respect to G or Z. Oh my gosh. Like you have to do like the determinant of yeah. It ends up being that because that's the cross product of a gradient. Here, I'll write it down real quick. Okay. If these are the right dimensions. Stop sharing. There we go. Okay. I don't know if these are like the right dimensions of the matrices, but essentially this is what's happening.
Okay.
And the trick is it's not a dot product, but it's a cross product, and I don't know why, but the reason it's called a curl is because it kind of goes perpendicular to it. It curls into itself or something. I don't really know but it's just some special thing that people use because fancy math, I don't even know. So if it was a dot product, it'd be pretty simple because it would just be like d over dx times dg dx. It would be the second derivative of g with respect to x.
Right, and that's what I did, but yeah.
But that actually doesn't happen at all. Everything else but that happens. Like it's partial of y of g to z. It's like it all like y and z are combined, g and z are combined, and or y z and y and x and z are
So
all
that
combined.
every part relates to every part.
Right, and the determinant is like the determinant finds it all, but none of it is like a dot product. I don't know where I found that, but like everything was like a cross product. So
I wonder where I found that it was a dot product. Like
I don't know. That product seems a lot more intuitive because that feels more like a second derivative in each direction. So that probably is used somewhere, and I don't know. Like there's probably a gradient dot product with a gradient of a function that is used. I don't know
for something.
I don't know what it is, but
okay. Well, okay. That is all the questions that I had on the quiz. Did you have any questions?
Yeah, I only missed like a point here or there, so I think it just kind of got it all right. Didn't show enough work.
Yeah,
so,
that makes sense. Okay.
For 2C, so or 2, so.
Choose. Which one?
2. We went over that, but
right.
Must have found the wrong answer. But I think I did all the work right. So, yeah.
Okay.
I am good. So, I think that covers the meeting, right?
Yeah, let's see. We did the questions, we did the quiz corrections. Yeah, that should be everything, right?
Yep.
Okay, cool. Super long meeting.
True. We went like an hour and a half, didn't we?
Yeah.
So, yeah.
Okay, cool. All right. Well, I will send you the link.
Sounds good.
Okay, see you next week.